Just like with numbers, when we simplify radical expressions that have variables in them, we can't leave any perfect squares of variables or perfect cubes or anything like that. Those need to be taken out as well. So in the first example, we've got the square root of 81 and then x to the 4th and y to the 8th. So to focus in on the 81 first, hopefully we recognize that as a perfect square. But if not, we can start to factor tree it, and we can break it up into 9 times 9. Now that gives us a pair of 9s underneath the radical symbol, so we know we're going to be able to take out a 9, and so we're not going to have a number left underneath the radical symbol anymore. Now when it comes to the variables, there's a couple of approaches that we can take. We could write it out the long way as a set of 4 x's and then a set of 8 y's, and then we just take them out in pairs. So just like we do with the 9s, we had a pair of 9s that comes out as a single 9. Well, here's a pair of x's, here's another pair of x's, so each of those is going to come out as a single x. So I'm going to have x times x on the outside, and then with the y's, here's a pair, another, another, and another, and so that means I'm going to have 4 y's that I'm going to be able to get on the outside. Now, of course, we have shortcuts for writing repetitive multiplication, so my final answer here is going to be 9 times x squared times y to the 4th power. Now, there's a shortcut for the variables that we could have used, and that makes things a lot faster. So in the case of x to the 4th, what we can do is whatever root we're taking, so in this case it's a square root, so 2 is our root, I can take whatever the exponent is and divide it by 2, and that will tell me what the exponent is, how many x's I'm going to be able to get out. So if I take that exponent, divide it by 2, 4 divided by 2 is 2, we can see we ended up with x squared on the outside. In the case of y to the 8th, if I divide that by, let's try that again. If I divide that exponent by 2, 8 divided by 2 is 4, and so we can see we ended up with y to the 4th on the outside. So the simplest way to simplify with variables with exponents is to take the exponent and divide it by whatever root we're taking. And so then that tells us what the exponent on that variable will be on the outside of the radical. So for the second example, this time it's a cube root, not a square root. So as I look to try to simplify the number part of my expression, 8 times 8 helps, but a pair of 8s isn't good enough. I would need to have 3 of something to get it out. So I'm going to continue with my factor treeing. So 8 breaks into 4 times 2 in both cases. And so then the 4s can break into a couple of 2s each. Again, pairs of 4s or pairs of 2s isn't enough. I need 3 of something to get it out. And so now I've got a set of 1, 2, 3 2s. It's going to come out as a 2. Here's another set of 1, 2, 3 2s. That's also going to come out as a 2. So now I've taken care of the cube root of 64 part. Now for the variables, I'm going to use the same thing that I did on the previous example, the shortcut that I used here, except now instead of dividing the exponents by 2, because we were taking a square root on the last one, I'm going to divide those exponents by 3. So 3 divided by 3 equals 1. So I'm going to have a single a on the outside. Basically, I have 3 a's on the inside. It's going to come out as a single a on the outside. And in the case of b, it's b to the 9th. So I'm going to divide that exponent by 3 as well. And so that equals 3. So that means I'm going to have a b to the 3rd on the outside. Or if we multiply the 2's, 2 times 2 is 4, a b cubed is our result. So again, we simplify the numbers just like regular, but with the variables, probably our fastest approach is to take those exponents, divide by whatever the root is, to figure out what our exponent of that variable on the outside of the expression is going to be. Now, we're not always so fortunate as to have everything come out of the radical symbol and have nothing left behind. Sometimes we have leftovers. So in the case of this example here, so for the cube root of 54, c to the 7th, d to the 10th, I'm going to focus on the numerical part first. So 54, any of a number of ways I could break that up. but I'll go with 9 times 6, and then the 9 breaks into 3 and 3, and the 6 breaks into 3 and 2. So right here, I can see I've got a set of 3 3s, so that's going to come out of the cube root symbol as a 3, but I have this leftover 2, so that's going to be stuck underneath the cube root symbol as a 2. So I've left a little space here because I also have to deal with these variables. So I've got c to the 7th, and I'm going to divide that exponent by 2. Now, unlike the previous examples, it doesn't, or by 3, I'm sorry. Unlike the previous examples, it doesn't divide in evenly, but that's fine. It goes in evenly twice. 3 goes into 7 2 times with a remainder of 1. And so what that means is, in my simplified expression, I'm going to be able to get a c squared on the outside. That accounts for the 2 that I got here, but I'm going to have a remainder of 1, so that means I still have a c to the first, or just c, that's left over underneath the radical symbol. And so then I can do the same thing with d to the 10th. So I'm going to take that exponent, I'm going to divide it by 3, since we're taking a cube root on this problem, and same thing. 3 does not divide in evenly, but 3 does go into 10 3 times, but then again with a remainder of 1. So that means in my simplified expression, I'm going to have d to the 3rd on the outside, but then I have a leftover single d on the inside. So we end up with 3c squared d cubed times the cube root of 2cd. For the next one, we have a 4th root. So that means I need 4 of something to get out from underneath the variable, the radical. Or in the case of the exponents on the variables, I'm going to divide those exponents by 4. But I'm going to first concentrate on the numerical part here. So 80, I'm going to break up into 10 times 8. 10 breaks up into 5 times 2. 8 is 4 times 2. The 4 breaks into 2 times 2. So I'm looking for a set of 4 of the same number, which indeed I have right here. I've got a set of 4 2s, so it's going to come out as a 2. But I'm still going to have this 5, this extra 5 that's trapped underneath the radical symbol. So I'm going to have a 4th root of at least 5. We'll see what happens with the variables. Now for those variables, u to the 7th, I'm going to take that exponent and I'm going to divide it by, this time it's going to be 4, since I'm taking the 4th root. So 4 goes into 7 once with a remainder of 3. So that means I'm going to have a single u on the outside, and then I'm going to have u cubed on the inside. I've got those 3 left over that I couldn't get out. For the v's, I've got v to the 8th. I'm going to take that 8, divide it by 4. This time it goes in evenly, I get 2. So that means I'm going to have a v squared on the outside, but I have no v's left over on the inside. And then finally for the w, I've got w to the 9th. I divide that by 4. 9 divided by 4, 4 goes in twice with a remainder of 1. So I'm going to have a w squared on the outside with a leftover w to the 1st, or just w, on the inside. So again, we simplify the numerical part first, and then we can use the root and divide that into the exponents on the variables to figure out how many get out and how many are stuck inside.